So, good morning, everyone. Today, we are going to have a speaker on freeform. We have today Mr. Irai Mudi from Graph 3D. He is the CEO of this company, but basically, he is a mechanical engineer and he has been involved in additive manufacturing for medical applications and has an experience of over 7 years. So, let's hear him on use of freeform. Geomagic haptic device and gain knowledge from him. So over to you, Mr. Raimudi. Would you like to share your screen?
Yeah, I will share now. Yeah, is it visible?
It's not yet. It's just plain blank white as a
Yeah. Okay, can we start, Doctor?
Yes, please.
Yeah, okay. Yeah, good morning to everyone here. So I'd like to thank Dr. Divya ma'am for giving me this opportunity to share my experience. Of course, let me start with this picture. Of course, this is exactly a picture of Operation Theatre nearly 100 years before. So you can see the picture, the surgeons are operating. Maybe most of the surgeons are much aware with this picture, so they, no safety. Maybe they don't have any glove, mask, or any advanced technology. But the thing is, expertise is always expertise. That is what I want to tell. The surgeons, they always work with the expertise. The technology is a kind of assist to make surgeons' life easy, to make their uh, planning, to make their planning and to do a surgery in a better way, like assisting that kind of thing. So this is a current operation theater. So there are a lot of instruments, a lot of instruments that there is different kind of surgical equipments are developed last over 100 years. Of course, most of the instruments has been assisting in the way of a tool, but okay, well, what is next? That's what the section today, of course, freeform, as Dr. told. But I like to start it generally. That is a medical additive manufacturing. That is 3D printing. Um, of course, it's a interdisciplinary. Maybe it's a kind of technology completely utilizing by the surgeons and also the uh, operating in the way of virtual planning. At the same time, it's a kind of interdisciplinary, as I told you before. The information and requirement, based on that we have to develop this technology. So before starting with the freeform, of course, freeform, maybe it's a kind of software, but I like to give you a complete idea, so how it works. At the same time, this 3D printing for medical is not only the designing. So it starts from the conversion of the CT data, and also it has to be a clear of selecting a material, selecting a technology. So I just give you an overview of material that we are using for a medical application, and also I will just give you a overview on how we are working with multiple products like surgical guides, implants, everything. Of course, maybe most of the people are aware about the 3D printing, how the technology works. There are a lot of different techniques, plastic based, powder based, metal based. There are difference there. So let me start. Why 3D printing is more useful in medical field? 3D printing has been initially using for a mechanical purpose like automobile, aerospace. So, but the growth of this particular 3D printing in medical application has been drastically increased in last 10 years. So only because the need, initially doctors are using the conventional technique like milling, so normal manufacturing process, but those kind of techniques will give you only the external. Okay, only 3D printing possible to achieve the internal surface. For example, if we are printing a bone, so we not only the external surface, we can also achieve the internal surface. For example, can print the cortical bone, we can find out the cancellous bone area, you can find out the pins. If you are cutting a bone, you will have all the information inside it. So information, so that's what a main uh, need, that's what a main advantage of this technology. At the same time, achieving this kind of complex structure, of course, uh, maybe a mechanical engineer, we always work with a parameter, but anatomy is non-parametric, it's an organic shape. So we can't create by using any primitives measurements. So it has to be achieved in a complex structure, customized. Of course, I used to do a lot of scaffolds, maybe to useful for the regeneration of a bone. Maybe it's quick regeneration of a bone, those kind of stuff. So by using this technology, you can achieve everything in the customized way. So by using a CT, MRI, CBCT. So before starting, this is a complete workflow. So for your understanding, so okay, if it is from the CT, for any surgical part, if you are planning for the model, so one of the input is a CT, MRI, or CBCT. The thing is, we have to get the data in a DICOM format. Okay, DICOM is a digital image communication on medicine. So this is the only format is applicable to convert as a 3D model. So the software, there are a lot of softwares in the market, of course. The general term, we call it as a image processing, that is medical image processing. This software help us to import the CT data as a DICOM format, and then help us to convert as a 3D model. So for example, if we are taking a skull in a 0.5 of slice thickness, it will have a 300 to 400 slices. The software will compile all the sizes together and will create a mask of the slice. For example, if we need a convert a bone, so there is a we call it as a threshold value. Based on the density, the software will capture the density value in the range of bone, then we can convert as a 3D model. So once we convert it, if we want to print as a model, you can directly print it and use it. If you need to design something, like you want to plan the surgery, for example, if you want to plan the orthognathic surgery, you have to do the leaf foot cut, any cut you can do by using the software. So you can do the virtual planning, you can create the guide or implant, then we can print it and use it together. Okay, so this is another thing. Of course, if there is a need of prosthetic, they're totally different. So 3D scanner, it will capture the external surface, so you can design and you can print by it. So another thing is a dental scanner. Of course, everybody is aware dental scanner. We can also use intraoral scanner for aligners, maybe our dental implant planning, anything. So this is a three different kind of inputs in this. This is what the complete workflow. So let me start with a few techniques. I just give you a technique, I'm not going to teach the technique. I'm just going to tell you how we are utilizing the base of material. So this is a SLA technique. So we are using this kind of printing technology to do some kind of models if needed in transparent mode. For example, this is a photopolymer based material. This material we will get it in a transparency, so for that you can see the nerves, you can print the root of the along with the tooth in a different color. Maybe you can also print guides, like for example, if you want to print surgical guides, dental implant guides, any cutting guides, like a surgical cutting guide for mandible or maximal or whatever maybe, we can print it by using technology. Because this machine will have a material called biocompatible for medical application. Of course, it's certified, because we can't use any material, because if other material, for example, if it is ABS or any plastics based materials, they will have a toxicity that may not be safe to use inside. That's what a certified material. I always recommend that. So this is one of the missions. So purely we are using for dental application, like aligners, surgical guides, a lot of stuff. So no, this almost having a 30 biocompatible material. So we are dealing with this mission. So we are working with this lot of products. Of course, we can also do the dentures, um, crowns, everything by using this material. The same kind, we are using this kind of material for surgical guides, because surgical guide has to be autoclavable. Okay, this only material will sustain a autoclavable temperature. You can use it, and it's certified, ISO certified. FDM, it's a basic technology. Of course, it's a very affordable, very cheap material. But this do a lot. We are using it for printing a models. Sometimes we design a post-operative model, like if some one half of the mandible has been defected, we used to remove it and we used to do a mirroring and make it as a normal mandible, and we print it by FDM. So the surgeons can bend their plate by using the models. This is also a same kind of models as well. Color, if you want to print in colors, you can print it. So this is actually ultimate the metal machine. We do a lot of patient specific implant in titanium TA6L4V. It's a customized implant. So I will show a few cases. So coming to software, so in software, maybe generally we call it as BioCAD modeling. So BioCAD modeling will have two different steps, like image processing and then designing. So that's image processing. We are using a software called D2P, die-come to print. That software will help you to convert a 3D model, and then we used to design any guide or something by using a Geomagic freeform with haptic device. So D2P is a software, maybe it's a certified software. Why I'm again and again I'm specifying with the certification, because I think doctor. So when we are converting any data, so we get only the die. So while conversion, there are a lot of free source softwares out there. So the conversion will happen based on the threshold range. So we should not able to verify whether the converted threshold density is correct or wrong. For example, if we are converting a mandible, if there is any error of 1 mm of offset of inside or outside, we could not able to identify it. We don't have any I think definitely we don't have any reference. We don't have any comparisons whether I have converted a particular patient data, whether the mandible comes in correct size, or where there is any error or something. We can't find the error only you operating the surgery. For example, if I created any implant by using a wrong data, I can design it, I can create a print the implant. So while operating, while placing the implant, it won't fit properly. Okay, so at the time we can't change anything. So that's the reason. So we have to be work on certified software like FDA. It means they have verified multiple of time and they got certificate of accuracy. Okay, that won't make any mistakes in the conversion. At the same time, D2P will have a automatic segmentation tool, so it will recognize and it will threshold automatically. It will make our life very easy, because initially for example, if I want to convert a mandible and maxilla, so usually in a condyle region there should be some connectivity in the data. If I want to separate my mandible perfectly, I have to do the editing process each slices. For example, if it is having a 150 slices, I have to erase every slice. No, it takes me 45 minutes to 1 hour. Okay, that's take a lot. If I miss any slice, for example, if it is a 300 slices, if I miss the editing or removing a connectivity in 150 or 160 slice, it won't separate. Again, I have to recheck the same number of slices. So it takes a lot of time. Okay, so to bypass this kind of difficulty, to bypass this kind of time taken, so here we have a automatic segmentation tool. So you just want to pick the required and non-required region, so it will automatically generate it. At the same time, it will help you to get a accurate data. So you can see some of the output. Of course, advantages, yes, D2P is a doctors friendly. You don't need to do a multiple of functional keys, like but what we are using as a CAD software. At the same time, you don't need to do any manual threshold fixation or anything. So it will be very quick to convert, easy to understand. You don't need to convert. Even when you're importing a diagram itself, you can see what are the inputs. So what are the data that is inside the CT. Okay, then you can easily diagnose this by using, you can simply you can cut and you can remove, like how you are using paint, those kind of, even it's not difficult like Photoshop. So virtually you can plan. Of course, we do a basic virtual planning of implant, dental implant placement, since we are able to trace the nerves. So basically we do the basic plan, and then if there is any existing screws and plates, we can also remove it. Okay, you can separate a bone. For example, this is a spinal bone. You can separate each and every vertebra very quickly. So in D2P, we have three different modules. Of course, bone module, tooth module, and vascular module. Here you can see the automatic segmentation tool. Once you import the data, so you can select this tool, and this is how you have to pick the required region. Here you can see that. So the red color and yellow color points. So it will mean that, so yellow is a required and the red color is a separated point. So it will automatically separate the condyle portion and the glenite fossa regions. Okay, here you can see the separations. So in bone model, of course, we can manually change the each and every model. The use of automatic segmentation is you can convert the bone very quickly in 3 to 4 minutes. Okay, so if it is if you have any scattering, for example, if the patient is already have any dental implants, they have any plates or screws or something, usually in CT there should be some scattering because of metal. Okay, so we can remove very quickly by using it. At the same time, the process will show that there should not be any bone loss. So that's what a big benefit. So here is a video. You can see that um, once we import the data, you can see the complete data. So this is what the complete CT. Okay, so it's not converted. You can see once imported. So here the data converted is a threshold range of the bone. Okay, the threshold value will be in numbers. Okay, once we import it, you just want to create as a mesh. Here you can see it, red color, and then we are selecting directly. In this case, the mandible and maxilla, we are going to separate it. So we are selecting the maxillary region. So this is what the complete 3D model of the complete data. Okay, so yes, we have converted. So this is a mandible. We just selected the mandible and we separated as a different file. Okay, you can see it here. So if you want to see the internal structure, for example, if it is want to see the porous inside the maybe the lesion extension, you can see it here. Maybe in normal view you could not able to see the internal. Okay, so cancellous bone regions. Okay, maybe the root region, everything. So you can see it in a transparent mode. So based on that, even you can plan it. Okay, if you want to do the resection, for example, if you want to cut the particular region, so you can just create a plane by drawing a line. Okay, with okay, once we create a plane, we can create a cut. So we are going to put another line in the front region. Okay, here you can see. So we made two different cuts. So this is a resected model, and then we will see the defected portion as a different color. We can change it to another model. So this is how it will quick. So for the basic diagnosis, so we can do the basic cuts very easily. At the same time, you can see the internal region in a transparent mode. Even you can measure by using this itself. So you can do the measurement. Okay, so even some kind of cases, if you're going to do some kind of implant planning, those kind of stuff, you don't need to print a guide. Okay, if it is very it's not a much complicated case, even the surgeons can measure it, they can virtually, they can understand, they can immediately they can operate it. So it will give you more information. If there is any requirement, we can go it for the models. So that's what a bone model. Maybe the tooth model is completely tooth extraction. Of course, it will help you to create each and every tooth. Okay, just picking up a point. Okay, so we have to mention the tooth name. Okay, you can separate multi-tooth in a single step. Okay, so you just want to put a point here, so you can see it here. So these are the multiple points. So once we create a point, automatically it will segment. Okay, you can separate the tooth here. So for example, we are using this tool for some kind of cases for a dental implant guy. So those patients, the doctors will take a CT along with the tooth. So maybe they are planning to extract a tooth while doing a surgery. So we virtually extract it. So at almost it exactly the same that they are doing the on table. So it won't give you the more bone loss. It won't give you that kind of it will give you of course 95 percentage of accuracy. We can plan based on that. So we are doing this kind of stuff. Vascular maybe totally different. Of course, we can track the path arteries. We can segment each and every arteries here. So very quickly at the same time, you will get a proper output like this. These are the cranial arteries. So we have converted this kind of things. At the same time, usually in some other things, we could not able to get this kind of accuracy. At the same time taken. So it just we have done in 1 hour. Okay, it's not that much easy, but if you are using some other software, it will take several times. So it makes quick. So some kind of cases, maybe neuro cases, maybe the spine cases, we used to do that. So apart from that, so basically the use of diagnosis, as I show you in the video, so maybe the same. So we can do the cutting. So you can create a plane. So and then you can cut each and everywhere. And also we can do the implant planning. Like you can see in the picture. So we can extract the nerve, okay, separately, and then we can see where it is located. At the same time, you can measure each and every place based on that. Actually, this software is only for the conversion. So we are utilizing by using a different tool. Actually, this is not an implant tool. This is a different tool to create a model making, but we can also utilize in this way. So we can create a cylinder, okay, like in the thing. If you have a implant library, for example, if you have a Noble Biocare or any implant library, if you have a STL file, you can import the STL file here. So you can import the STL file into the software. You can plan based on it. The only thing is your planning is not only in the 3D, of course in the 2D. Okay, so I will show a few cases. So this is okay. First of all, sorry for the music. I think you may hear. So I removed it. I don't know how it plays. Okay. So this is a video. You can see if there is any existing plates and screws. If we are planning for the uh, reoperation, maybe planning for the. We have done few cases like removing the existing plates and screws, planning a new surgery. You can remove it exactly. So you can see it in a video. So the screws and plates will have a different density. You can pick it and you can remove exactly. At the same time, this is what maybe in a transparent mode using a diagnostic tool, you can do the create a plane. Creating this kind of planes, usually it will take much time for us. For example, if you are maybe the same, you can also do it in Geomagic. um, if you have a only this software, you can do it this much. Maybe you can cut it. Maybe you could not able to do a mirroring, those kind of stuff. Maybe basically you can do the virtual planning. This T2P is exactly to convert data properly and then do the basic cutting and planning process. So if you want to design something, definitely we have to go to freeform. So apart from that conversion, so yes, if you want to design, we are going for free form. Then we also have a module called VR, virtual reality, um, maybe some kind of heart surgeries like pediatric surgeries, those kind of. We helped a few cases in Mio. We used to print a model. Some kind of cases the surgeons don't have that much time to print a model. For example, if you want to print a cranial full skull, it will take 15 hours in FDM machine. In SLA, in big, even a bigger machine, it will take more than that. So some cases we could not able to wait for that much time. So we just convert it, and we can virtually diagnosis maybe by using a so D2P. Even we can use it by free form. VR is another method. So you can also do it in a. We have a goggles. They can do the virtually. They can plan it. They can measure it. Probably VR. They are using it for a more teaching purpose, educational purpose. Um, of course, we have a lot of editing tools. Maybe editing tools is not much useful for surgical procedure, but it will more useful for the study purpose. For example, if you want to do a FEA CFT analysis, so we have to prepare the file. So preparing the file is a very big task. Each and every file. No, as a mechanical process, so we always work in a regular template, but in medical it's totally different. Each and every case is a R&D for us. For example, if we are printing any converting any data for a patient A, patient B is different. Since we are working on the same model, because the patient data will different, the density will different, the possibilities, the difficulties, everything. Each and every case is a kind of research for us. At the same time, we will face problem in each and every case in a different way. So that's what the thing. So converting a data, editing a data, preparing a data is totally different. Of course, we have all tools to go for the second level of analysis or validation process. VR, as I told you, they are using it for teaching purpose. Yes, we have two different models. One is mesh and volume. Maybe a mesh is a model. Once you convert in a D2P, you can see it in a virtual reality. But volume is it's really different. You can directly import the DICOM data, so it will ultimately convert all the tissues like soft tissue, nerves, everything. You can see the complete human body like real things along with heart, bone, everything together. It's a quick process, maybe some kind of requirement. Okay, D2 image processing, of course, it's a initial step. You can conversion for the models and preparing a thing. So BioCAD modeling is a major thing. So it's changed a lot. We have a lot of CAD softwares here, but we are not able to utilize those kind of CAD softwares because we can't work in a parametrical way. In maybe 5 to 6 years before, when I get to know about this device and software, and then at the time myself and Dr. John Nason starts, so we are together. So we started working with these applications. Initially, they are using it for the sculpting. You know, they are using in a different way, sculpting, toy creation, and everything. But the device is a magic. So the haptic device will give you the touch feedback, so you can feel the consistency, maybe the thickness of the bone. You can feel the surface of the bone. You can do the cutting. Okay, you will feel the cutting consistency, like when we are cutting a cake, we feel the consistency of the cake through the knife, like that. We can do the real way of understanding. So it's probably for example, if you are creating some kind of implants, we want to do a virtual surgery, you can do the cut, you can place the implant, you can put the screws there, you can see the angulation, that much helpful. So it
Yeah.
will completely assist you in that.
Mr. Raimati, can we break at this point just to
Yes,
discuss if there are any questions on D2P before we
sure,
proceed
sure.
to freeform?
Sure,
So
ma'am, sure.
usually you use CT data, but have you used CBCT data as well for
Yes,
in
maximum
D2P?
we use CBCT. Maximum we
So
use
how do you
CBCT
take care
because
of the noise? Because in CBCT there's so much of noise as compared to the CT data.
yes, ma'am. But
So
ma'am, actually, the noise is not in all the data. Maybe some data, sometimes we'll get a very good data.
mm,
without any noise. If the patient is having any two implant screws or anything, definitely there is a noise. That's what we have a magic the tool we have in D2P. So that tool will help us to avoid only the noise. It won't disturb the bone.
okay.
So exactly it will remove only the scatterings. We call
Mm,
it as a scatterings. It exactly remove the scatterings. So it will be very useful. Usually, initially, how we will do is, I used to select each and every slice,
mm,
manually erase it.
mm.
Okay, so maybe we have understanding. So maybe I have, with my experience, I can understand this is a bone, this is a scattering, but not every new peoples can understand. Maybe non-doctors, I am telling about biomedical engineers, everybody. For that only we are using this tool. So the tool will not erase bone, it will erase only that scatterings noises.
Any
So most,
particular uh, setting you suggest for taking the CBCT so that the scattering is least?
no ma'am, the setting we always suggest with the slice thickness zero point 0.6 or less than zero point 0.6 slice thickness, all in sagittal, coronal, and axial. So the setting, definitely no CT scan centers will not change the settings. Even I'm not much aware about the settings because it's already templated. The only thing is we ask them to take a minimum slice thickness as possible. So minimum slice thickness will give you the higher accuracy. For example, if they are taking a slice, maybe in CT or CBCT, whatever may be, slice thickness is 1 mm or 2 mm, the data will be not that much smoother. So it's not a that much accurate data as well. We always advise to take a zero point 0.6 or less than 0.6 mm of slice thickness.
Okay.
It's also general.
Yeah, that is the general tendency. We use
Yeah, yeah.
5 mm data slice
Okay, ma'am.
thickness, or
Okay.
1 mm
Yeah.
or 2 mm. So that is what we prefer in CT. But with CBCT, I don't know how much slight thickness we
Same,
get.
ma'am.
But
Same, ma'am.
same.
CBCT also we are getting, you know, and maximum 70 to 80% of cases we are working with CBCT only. I always prefer CT. Definitely, I need CT for implants, customized implant. If I want to create any metal implants, we use only CT. Otherwise, maximum of institutions they prefer CT, CBCT only because ethical committee they will not accept. Usually,
Yes.
the professors will do that. So
Yeah.
we work with CBCT. That's not a problem.
And the other thing you said, that using D2P is very fast. So what is
Yes,
the another software for doctors only is ProPlan. So as compared
pro
to
plan. Yes,
ProPlan, yeah, what do
yes.
you suggest? D2P is easier as compared to ProPlan, or it's somewhat
Uh,
similar? Have you
ProPlan, I
used
think
ProPlan?
I have used very minimally, man, because I have attached with some company. I can't use another companies, but I was experienced with Metalize. You know,
Yeah.
I was working with Metalize nearly 8 years. So my research is on Metalize software only. So conversion, everything. The difference between is quicker. So for as I told you, no, so I have to edit each and every slice. So by using Metalize, we have to edit each and every slice. So that's an advanced one. This specifically for make it doctors friendly. At the same time, ProPlan, I think you can use it for orthodontic planning, those kind of stuff.
Mm,
It's automatic, I guess.
yeah. Okay.
So
Any
you can do
questions?
it.
Any questions from the audience? Anyone wants to ask? Please unmute and ask the question. Sumit, Kananika,
Yes, ma'am.
any question?
Yes, ma'am. I have a question.
Yes.
That hello.
Yes, yes, yes. Tell me, doctor.
Uh, 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 what other software except D2P and Mimics are there for this sort of work?
Yeah.
Because every company I came across says that the same thing is to be done through Mimics as well. In that we select few sections and then it automatically do the noise
mm,
removal, and that is the
But
same what you are
no, in
in
Mimics, you have to change the threshold value. So you have to change the threshold value. You have to edit it. Maybe in
because
Mimics, you have to select it,
through
and you
changing
have
the
to.
threshold value only we can appreciate the difference between the bone and the noise.
No, if you are manually changing the threshold value, so we could not able to assure whether the changing threshold will affect the bone density. Sometimes it will affect, you know. So if it is there is reducing the density of 0.1 mm, we could not virtually diagnose this. So that's what the tool that we have to use, automatic segmentation. So of course we can use it. I am not telling it's a wrong. Maybe it's a better way. So that's an option. So each software will have a different option. So each will have their competitive tools in that way. So this software will make you quick, make you
And what
quick. So
other
because
free What other free options are available, like for the same work except the D2P and Mimics?
Other softwares you're asking, doctor?
Yeah, yeah.
The softwares, of course, I recommend D2P and free for
No,
Mimics.
that I understand
Okay.
it because you are dealing with D2P, but what other software
No, no,
options are
not
there?
D2P. I am telling D2P and Mimics. Okay.
Yeah.
Apart from that, there is a software called Scan IPs on more software. Renisha, they have some software. I'm not sure how they are using it for conversion. They are using it for cranial implant something.
Okay.
GE have some basic softwares. So I was not
Mhm.
much experienced with other softwares because these are the two softwares. Universally, they are using it. Mimics is for a very long time. D2P,
Mhm.
we are using it for last 6 years.
Thank you.
Sumit,
Yeah.
did we get D2P along with the freeform Geomagic?
No, no,
No, ma'am. No, ma'am.
Yeah.
no,
D2P is a
ma'am.
different software. Freeform is different, ma'am.
Yeah.
Mm.
Okay, please go ahead.
Okay, okay, fine. So, as I told you, so of course, D2P is for a conversion. So, I'm coming to BioCAD modeling. So, freeform, and the device is we can use it in of course it's more doctor friendly, when we call it as a designing. Of course, before I have used a 3matic is another software. It's materials based. This software we used to have a kind of tools. We can't create any shapes very quickly. We have to take it from the primitives. For example, if I want to create a block, like here, I think you can able to see my mouse point. So if I want to create this kind of structure of block, I have to create multiple of primitive shapes like cylinder, square, cube. Then I have to smoothen. It takes long time for us, So initially we struggled with it because, of course, to creating a surface it's very easy, but creating a organic shape, it takes a time. So then only we started using with freeform. It's very quick. There are a lot of shapes here. It's a kind of clay form, maybe how doctors, dentists are using a wax preparation. The same thing, you are preparing something in a software. So just to sit a few hours, you can understand once you understand the device sensibility, then you can work very quickly. At the same time, the designing will take very, very quick process, uh, definitely. So the person, she is working, she's a dentist. She's the one who do the virtual planning of the implant and everything. The only implant design only I will do. The basic things they are doing it. So of course, we started with the orthognathic surgery. So I did a first orthognathic surgery in 2015. So with John sir, we have done lot of orthognathic implants. Of course, we can do the same cut like BSSO, leaf out cut. You can do the advancement, So this is a picture for understanding. So in D2P, of course, we could not understand the software movement. Okay, but you can do the soft tissue movement, but you can see the soft tissue. You can convert it, but it won't give you the same texture, but it will be like a bone hard thing, but you can see the soft tissue. So we can convert the soft tissue by the, but you can use it for complete virtual planning. For example, if you want to do the advancement, you want to do setback, angulation, tilting, everything you can do it up manually for your verification without parameter. If you want to plan completely, you can also do the movement with parameter also. You can do both way. So to finally we can find out the proper cusp. For the cusp, we used to create a sprint like this. Maybe most of the people are aware about it. Orthognathic sprints. So that's what. So the sprints will help you much on to achieve the cusp level. So apart from that, the second level is for maybe the trauma cases. Of course, in anatomy, I can't design myself. I can't design anything in a structure. I can't design anything in surface level. So always I have a reference within a data. I take a opposite side of the patient. If some cases, very rare cases, we don't have a reference because more than 50% of anatomy has been defected or something. We create based on the margin. We have some templates. I created my own templates to achieve the profile. At the same time, we at the time we consider the soft tissue margin, so we don't consider a lot of parametrical things to design it. It's very quick in the process, the smoothing, everything. um, of course, it's a guide preparation, so we are doing a lot of fibula planning. So you can do the virtual planning, you can cut it, you can also take a fibula, so you can place based on that we can create a guide. So we have done a lot of cases like that. This is a simple video. So okay, this will not be that much understandable. I can't do it a training in a 1 hour section. Of course, I just give you one of the video. We design a subperiosteal implant very quickly, so you can see it here. Of course, it takes me 15 to 16 minutes. I just shorten the video here. You just want to select the surface to create any part. Okay, so this is a tool selecting tool. Once you select it, you have to cut it, and then you have to do the offset option. So then smoothening process, in freeform there are a lot of tools are there, there are a lot of, because it's not for a medical, so we are using it for a medical. There are a lot of tools, so we can utilize a maximum tools, but I'm tell you, only 6 to 7 tools are utilizing it, maybe for a medical, for creating any implant or planning anything. Selection tool, smoothening tool, maybe a duplication tool, and a profile projection tool, patterning tool. So this is what the few tools that we can use it. So I'm just giving an abutment here. So we have some library. If you have any direct implant library, you can utilize the abutment. Maybe now there are different kind of abutments, or ball abutment, those kind of stuff. If you are able to get the STL files, you can get it and you can directly import and place it. It will be easy for you to the post-surgical process, like tooth placement, denture placement, those kind of stuff. So this is actually it's understanding thing. So usually we will place a maxillary and we will see the angulation, a lot of stuffs. Okay, sometimes most of the cases, if we don't have a reference, we also scan the denture to find out the implant angulation, those kind of it completely depends upon the surgeon's requirement. We are just designing, so we are just designing based on the input and requirement of the each and every surgeons. So once we created the structure, this is a screw placement planning. Of course, as I told you before, this is not only the external plan. We have to plan internally. So maybe there is a nerve is here. So based on that, you can see it now. So here is a converted 3D nerve here. So we can vary, we can measure, we can control the depth based on that. Okay. So placing multiple of screws. So you can see it in 3D. Okay, I'm just creating a holes, the screw placements. So it's a simple Boolean option. Okay, so if we don't need this number of screw holes, you can also reduce the size. So you don't need to go much region of unwanted. At the same time, um, smoothening the process. Actually, this implant, actually we printed it for one of the surgeons. So Dr. Hoshing, so he's a dental surgeon. So we did it for a demo purpose. So you can see it here in transparent. You can also see the attachment of the bone. Okay, so you can do the smoothening in each and everywhere, because since we are going to print it in metal, so we can't do it after printing. So has to be very conscious. So this is how we can design an implant. So freeform will have a multiple of tools. So for example, I can't add up multiple of videos on freeform, because it's each video will take 10 to 15 minutes. Orthognathic planning. So you just create a plane. You can do the cutting, and you can do the movement very quickly. It makes a very easy way of virtual planning. So of course we can also design an implant here. Okay, let's so far I have explained you about a software, how we are utilizing a software. So without example, I can't do anything. So maybe I can say this is, I can do this, I can do, we can create something, we can create this one. So I just like to share few of our cases. So of course, implant, patient specific implant, so far I have done nearly 100. So we have going to reach 100 soon. Most of the cases we do superior stream in a simple way, mandible, maxillary reconstruction. Cranial is a one I used to do a lot. no cranial frontal bone. We do lot of cases on that. So I like to show few cases. Maybe the first case may not be related to the dental, but I just like to share this case, spinal guide. Maybe it will be useful. You can implement this application into any of your things, because nothing is standard. So this technology will assist you to do a help you in any difficulty of your surgery. So any kind of problems, it will help you to solve it. So this is fine. You have a screws and plates, it's failed. Okay, you can separate. So this completely merged, it's one of the difficult case we have done. We are doing lot of cases like this. So we separated each and every vertebra as much as possible. So this is what virtual planning. So we used to do virtually plan. So we did a screw placement here. Informations, what will be the screw size, how much it will be possible. So what will be the screw length, this is what the length you can place it, something like that. So simple guide, like a dental implant guide, we do a spinal guides. We printed in a photopolymer, as I told you. So it's a medical grade. We printed in a 3D systems figure 4 med. So autoclavable, definitely we have to autoclave before it. So they have just placed it. So we'll open it, they have placed it, they will put the screw holes, and then we'll take it, they're putting in real screws. You can see it here. So this is what the output. So this will be maybe you can use it for any kind of surgeries, like uh, maybe there's a concept, I'm just sharing the concept, so you can use it for things, because each and every case we have a new idea. So we are giving a different kind of solutions. So the only thing is we can do a lot of planning before doing it. You can see the pre and post. So coming to dental cases, of course, this is one of the all on 6 implant, Dr. Pratisha. So I just mentioned you a surgeon's name before, because if you have any surgical doubts, maybe you can ask them. So I just show what we have done. So it's a case we converted in D2P. The main thing is this particular, excuse me.
Richa, please mute yourself, Richa.
Yes, okay. So this is a case for usually for a dental implant guides, we can't. This is a case they want to do without flap, without opening flap. So we take a CT from the, I mean bone data from the CBCT. We converted it, okay, as a 3D model. Then we superimposed the denture. Maybe usually we some cases we have a tooth, so we have a reference to superimpose very quickly. Sometimes we have if we have a tooth, I always take a 3-point fixation, maybe in a front, one of the incisor or molars. We'll take 3-point fixation. Based on that, we'll superimpose it. We measure based on the multiple of reference. But this case we don't have much reference. The only thing is in D2P, once you are importing any STL file, you can also see the file range in the 2D. For example, here you can see the bone data. This is a completely a soft tissue. Okay, so this is a gingiva level. So based on the gingiva level, you can virtually superimpose it. So no other software will help you do this, because maybe in importing STL file, it won't show in the 2D view. So that's what make you to more accuracy in the superimposition. So virtual plan. So usually the surgeon will sit with us. So they will, or else we will sit in a video call, a Skype call to plan it. So basically we will place the implant based on their requirement, angulation. We'll send them the each and every step of placement. You can simultaneously you can see it in a 2D as well, 2D view. So here you can see the implant. Even you can adjust based on this view, okay, in 2D as well as a 3D. So this is a designed guide. It's a very simple guide. So guide designing is not a big thing. So only thing is we have to create this kind of cylinders and maybe a drill point, 2 mm pilot drill and step drills. We have to create some kind of basic library. Then you can just put it and place it and boot in it. That's what you can do it. So this is a designed implant guide. So printed here. So they have placed directly. Okay, we also give some fixation anchoring screws position, so they can do the anchoring here. So you can see the placement of the screw holes. So this is what the post-operative image. So OPG. So you can see how much we can achieve virtual and also the real surgery. The guide, of course, a lot of people are doing a guide. So it's a general product. The same kind, it's a simple surgery. So maybe 2 implants, 2 to 3 implants. We operated in Tagore College. He's a professor from Tagore College. Uh, so again, so as I told you, if we have a tooth, it very easy for us. Maybe same thing we will do in a 2D and 3D, both of things. So even this case, basically we plan with the D2B itself. So we just extracted because we have to find out it should not touch the tooth, existing tooth root or anything. So it's a design guide. So this is how they have placed it. So they put a pilot drill, then they can put it each and every level. Okay, you can see the implant here. So this is our PG. So they have placed the same implants. Okay, that's what example for a guide. And then virtual planning. So this is a wonderful example. So this we operated in GH, Dr. Sedarajan sir. So we designed it. They don't have much time. So I get the CT data in a one day evening. So they want to operate in the next day morning. So we just do a quick. We just remove it and do the mirroring option and make a proper zygomatic and the orbital floor with calculating the volume of the orbit. So just a simple, it won't take much time to do a design asana. We just selected a normal mirrored data, selected the surface, and we printed this model, these two models with a FDM machine itself, a PLA. PLA is one of the material. ABS, definitely we can't use ABS because it's toxic. PLA, polylactic acid, is compatible. But I don't prefer to use it for a much complicated guide. So they have used it to bend the plate, I guess. So for that, they are not going to directly place it into the thing. So they can use PLA, but PLA is safe, not that much accurate because we are using an FDM. So FDM is meant for models. So this is what the output. So this surgery is very good. At the same time, for patients, they can't afford much. So the solution should not be a not be for the affordable only. We have to be help them for the non-affordable patients. So it's not mean that we can do only implant. We can also do a basic model. 2,000, 3,000 rupees model is help much to do the planning a surgery.
Thank
Same.
you. Can I ask a question
Yes.
in between? Yeah.
Yes. Yes. Yes.
What all we are seeing is most of it is for maxillofacial use. But
Yes,
apart from maxillofacial, have you used your freeform for other specialties in dentistry?
Other specialty means what do you mean, ma'am? Any kind of surgery or specifically?
No, not surgery. In dentistry only, there are several other specialties like in orthodontics or in prosthodontics. For suppose for designing of ear.
Yes, ma'am.
No.
Designing of ear, yes, we have done it 2 to
Yeah.
3 years.
Could you
Same
speak on
Dr.
that, please?
Sedarajan.
Yeah.
Ma'am, I don't have those slides, so we can't show all the cases. That same thing we have done it for Dr. Sedarajan sir, because that's the case I have done in my previous company. So maybe Dr. Jan sir, so he will have the pictures. I can't show it right now. I don't have it. We have did a prosthetic kind of ears in a silicon based ears. So we just did a models, those kind of stuff. And in other applications like ortho, of course, we have planned aligner base thing of studies. We have done a lot of things. So bracket placement planning. We did a tooth measurement to find out virtually a proper location to place the bracket. So we prepare a guide, something like that, and then we created kind of a simple guide for a root canal treatment. Maybe I did one of the study for a student of Dr. Hannah Joseph Madam in SRMC. So for their studies, we did a guide for a root canal treatment, those kind of stuff. So that's what we had. Most of the things we have done it for a basic dental, maybe a dental implant. That's what we usually do. Other things we do a lot of thesis work like surgical planning, any kind of virtual assisting. We do the thesis work, but our commercial regular work is like a surgical guide, virtual planning of the surgery, preparing different kind of guides, and implants. Implants is it's my major product, so I do a lot of implants, customized implants. That's what.
Thank you.
Okay. So this is one of the case. We operated Dr. Sendel. It's a Savita, Chennai. So I'm not much aware about this project. This is a first experience for us. They want to do a virtual planning. It's kind of very monthly aged baby. So we did virtually, we do all correct cutting. There are a lot of parameters involved here. Maybe I'm not much aware, so maybe you guys are aware. So we did all parametrical cut here virtually. So I just also we have done movement advancement and a lot of planning the doctors require. Okay, you can see it here. So it's a simple guide. So this is a guide that will help them to do the same cut. It will reciprocate in the surgery in the same level. So, and also this is a small kind of block, so it help them to advancement to find out the proper measurement advancement. There is a stopper here, they just placed and fix the advancement. So this is what a 3D printed guide. So I don't have the surgical images. Maybe that's why I mentioned all the surgeons. If you are known to him, then you can also ask them. So subperiosteal implant, we are doing a lot of cases. It's a very usual for us. So for Dr. Karthik, so we did together this case, sponsored case. So very quick design, as I showed you in video. So maybe it shows a little bit thick, and because the photo they have given a very zoomed. It's a thickness of 1.2, 1.5 mm. So this is operated image. So you can place the see the implant here. Of course, it's two years old cases. Sorry, 3 years old cases. So after placing him, so he doesn't utilize all the screw holes. So he just plays a few. They don't need all the holes because he get a proper fixation in that itself. Same, it's a Hyderabad case, Dr. Shravan. Okay, so which will you plan it? So if it is not possible to do dental implants, he required the same subperiosteal very quick implant. You can see it here. So customized implant. So far we have show you some kind of guides and maybe dental level of surgical things. So something to customized, we always concern with the three fact like form, function, and aesthetic. Few cases, maybe this is a case that we have operated in Erodu. It's in 3 years before. No, the cancer kind of case, I guess. So they have already removed the first level of treatment. So the doctor came to do me to design an implant. So we just extracted all the tooth in D2P itself, and then we removed few bones level, and then we design an implant. So maxilla, we designed 2 implants. So it's totally a different concept. I'm not using the concept for all, so because it's a surgeon's idea. So he wanted to do it in that way, and also the mandible implant as well. Here you can see the 3 implants that are stretched. So 3D printed. So of course we do print in a metal like TA6AL4V. It's a golden standard titanium. Okay, so of course in 3D printing, if it is dental, you can use cobalt chromium, but in surgical implant like this, I prefer only titanium. So you can see the both implants. So this is surgical images. So you can see all the 3 implants. This is a case in Tamil Nadu. We operated as a very young patient. So may you know that in transparent mode you can see the lesion, how much it's extended. So usually the safer side, the surgeon asked me to put a 10 mm of margin. So we do the cutting. It's a cutting guide. Always we prefer, if we are placing an implant, we have to give a cutting guide, because the cutting cut placement has to be exactly where the implant has sit. So if it is 1 mm of variation, the implant would sit, has to be carried. So this is a design implant. Along with the abutment, we designed it. This kind of design is not possible for all the cases. Some case, if we don't have a better soft tissue closer or something, maybe we can't give you the abutment. So it's purely based on the surgeon's requirement. Okay, so
I need to ask a question. May I interrupt?
Yes, 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 please.
As the images you have shown that you have placed the abutments. Have you performed any analysis to confirm that this type of abutment is ethically right to
Sustain the
place?
load. Yeah,
Yes,
yeah.
also.
I'm not tell you the ethically, because in designing, maybe we can design based on that. Because if we are placing a, for example, what is it? Bone graft. If you are placing some kind of bone graft, if you are placing a fibula graft, so same kind we are going to place the bone there, and then we are going to place a dental implant over there. The same concept, but we are completely fitting in the metal. Of course, surgical point, the surgeon has to approve whether it is better, whether they will able to get the soft tissue closer. Okay, whether they are able to do without any further of infection or something. But in maybe mechanical point, of course our implant will sustain the biting force. Okay, so we do analysis Okay, the thing is,
What
uh,
analysis you performed for evaluating the biting force?
FE analysis. So biting force is a 500 Newton completely. It's maximum. I'm telling it's almost 500 Newton. The usually the minimum thickness of the metal will sustain 4 times higher than that. Okay, so 4 times higher than that. So we have a template. So that's what. So but we are not doing it for each and every case because the parameter that we are using is a maximum safer side. So we should not go beyond some parameters. So I have a template. Even the each and every holes. For example, in this implant, you can see the multiple of square holes. This we call it as a scaffold. Okay, each and this scaffold, this screw placement, this size, thickness, everything has been we template. I have templated it. So it's all involves my research, 4 to 5 years of research. So I have a template. That's why I'm putting all the parameters on that. So we are sure this design or this apartment will sustain 4 times higher than the required biting force. That is what occurred.
So that has to be performed for every customized implant, I suppose.
Yes, of course. That's what when I used to design an implant, I have a basic template. I should not go beyond that measurement. So that's what I have it personally. So that's what we are doing. So far we didn't face any failures in any of our 80 to 90 cases. So that's what the reason, because if we are giving in without understanding the load bearing, without understanding the screw placement, whether for example if we are placing this kind of screws in the condyle region, we have to
Hmm.
sure whether the condyle will sustain only by using this number of screws. We will do the basic analysis here. We will do the analyze the strength of the screw placement, density of the bone, simple analysis. So it's a kind of template. So I created a workflow template to understand
Hmm.
each and every steps. So that's
So
what. So
one is FEA you are doing, and what another anything else apart from FEA?
only FEA. Only in analysis there are two things. One is FEA, okay, and the CFD. CFD is of air flow, fluid flow, those kind of flow analysis. Any stress, strain, load bearing, anything is FEA only. Only FEA.
Another questions, a very small one. That
Yes.
do you print screws as well, or you use the commercially available screws?
We use a commercially available screws. We are not doing screws because screws is a very small part, so we can't
Hmm.
do it in a one or two numbers. It's commercially it available, so we just give you the screw location of 2 mm or 3 mm, so we don't need to print it. It's higher in cost. We
So
don't require that.
in places where there is less of space, so how do you manage that?
No, the usually when I design the implant, I used to measure each and every place where I am putting a screw. I suggest a surgeon, here we have to put a screw of 8 mm. Here we have to put a screw of 6 mm. Okay, the implant itself guide the angulation. Okay, so the screw hole will itself guide the angulation. So each and every place we used to mark it and send to the surgeon. Here you have to order 3 6 mm screws, 4 8 mm screws, like that.
Any
So
shortcomings in printing the screws, or any challenges in printing the screws if we try to do?
3D printing, maybe you hear 3D printing is everything is possible. That's not, it's real fact. We can't print screws very easily because it's very tiny. So screws preferably in milling process only, because at the same time we can achieve it, but it's a very long process. If you have to pay for a single screw to nearly 1 lakh, because it pays a number of procedures after to achieve the thread, everything. Maybe it may come in future. Oh, we can't guarantee anything, but so far, using a standard screws is more than enough. We don't need customization of the screws. Why we need 3D printing means we are creating customized implant. If we are going to place a standard means we don't need a
Yeah.
3D printer here. So because comparatively it's cost effective.
What
Okay.
is the smallest size have you ever printed? Like a dental implant? Have you ever printed a dental implant sort of thing?
I have printed a very smaller size of like orbiter floor of 0.6 mm of size thickness, 6
No,
mm.
I'm talking about the screw. The anything
Screw.
which have a pitch.
No. I don't have. I never printed any screws. We tried. We tried for one of the thesis. We are able to achieve it, but not that much perfect. No, like
Okay.
wiring process. No, so
So
far not advisable to do that.
so
Screws.
it is not feasible for us to print a customized
Uh,
dental implant sort of thing of.
no, it's feasible. Definitely, it's feasible. I'm not telling it not feasible, but it's not affordable right now. Okay, not only
Okay.
printing is, for example, if I want to print this implant, this is not a
Hmm.
direct print product. Okay, there are a
Yeah.
lot of support metals are there. I have to do the milling process. I have to do the surface finish. I have to do the heat treatment. I have to do the ball milling. There are a lot of certain post processing procedures are there.
Yeah.
Okay,
Yeah.
screw is not that much easy to achieve.
Yeah.
Okay, definitely it will achievable, but it very high in cost.
Okay.
But no, a few of the doctors will ask me to do a dental implant thesis. They want to create some kind of thread, different kind of thread. Okay,
Yeah.
so I usually advise them. It's not possible currently. It's not easy to do in 3D printing. You have to pay much for it. Okay, we have to do multiple of process. Currently, it's not available in India as well.
What minimum pitch we can achieve? Like, have you any idea what minimum pitch we can achieve if we
Actually,
try to do some?
what I'm telling is minimum pitch, right? Minimum
The
structure is
difference
we
between the
can
two threads.
even we can achieve 0.6 or 0.3. Okay,
Okay.
but metal. But the thing is, pitch is totally different.
Yeah.
Pitch is totally different. Inside a pitch, there is a concept called design for additive manufacturing. There should be some support material. It's deep
Yeah.
into the designing process. If in between the pitch, there should be a support will generate. So when we are removing the support, there should be a possibility of damaging the pitch as well.
Okay.
Yeah.
So
Thank
the
you. Thank
everything it deals with.
you. Yeah.
Yeah.
Okay.
May
Thank you.
I ask one question?
Yes, ma'am.
The
Yes.
titanium you're using is what grade?
TA6AL4V,
Yeah,
grade
but
5. Grade
grade
5.
5. But usually
Yes.
for medical implants, we are supposed to use grade 23.
Same, ma'am. So the same, only one grade. The thing is, in medical, general medical, they will use it in a different values. But I can't use it in my way because the material that I want to print is I have to get it from the machine manufacturer. So they have a certified material. Maybe that includes a we combination. We call it as a TA6AL45. The
Yeah.
same material that we are using for denture, those kind of stuff. If it is in titanium, same material, everything is same. So the term we are calling is in a different way because specifically it's made for a 3D printing. So
Okay.
this is not a material I can buy it in a market and use it in my machine. So everything is it's controlled
Yeah.
because of
And
the FDA process.
yeah, and the other thing is the regulatory approvals in India.
Yeah.
What is the status of the regulatory means
Actually, we have a machine, metal machine.
uh,
So okay, maybe I'm going to work with another company in the end of this month. So Sri Rapid. So we have a metal machine. So we are going to get all the certificate here. So it's placed in Mumbai. We have a complete setup for a medical, metal, plastic, SLS, everything. Maybe next dental machine, everything together. So the regulatory so far they are asking it of IS. So the main thing is we have to use a machine has to be genuine for a single material. If somebody is using a single machine for another material, for example, if they are using some aluminum, if they are using some stainless steel, it's non-medical grade, there should be a possibility of contamination. Okay, of course we can do autoclave, we can sterilize whatever may be. The contamination is inside the part. Okay, it may not reflect immediately, it may reflect later. So ethically you should not place that kind of contaminant. So the material has to be genuinely using for a single material. At the same time, the post processing, they have to do the heat treatment. So there is a certain procedures is there. So we usually get it from Belgium. Okay, it's our 3D system company. The same setup we are going to put it in Mumbai, maybe in next 3 months. Okay, that's purely certified. So we have
yeah.
ISO.
Thank
We
you.
are going
Thank
to
you.
get the
There's
FDA
one
certified.
more question from Dr.
Yes,
Abdul
ma'am.
Hamid. Abdul,
Yes,
please.
ma'am.
Hi, doctor. That is a very good presentation. I have few queries as well as my experience to share here.
Yes, doctor.
Yeah. See, first thing, this mandible, what we are discussing with the studs on the surface of upper border for the dental rehabilitation.
Yes, yes.
With these type of
Sorry, doctor, it's breaking. I can't hear you.
Abdul, we can't hear you. I think he has left.
Maybe I have very few slides, ma'am. I can finish it
Yes, please.
quickly.
Yes, please.
Yes.
I
So
don't know
this
if
is
you'll be
the
understanding
surgical
this.
image.
Other doctors will be understanding this. The flap once we cover with the metal, okay, this studs coming out of the incision line.
Yes, doctor.
That will give you a lot of problems in the future because we had a lot of problem with such kind of an implant because initially we need something which has to be covered totally, that the implant should
Mm.
not be exposed anywhere because there is will not be having any kind
Yeah,
of a
yeah,
soft
but
tissue attached.
Abdul, we should not,
One second.
Abdul, we should not talk to him about the particular design because that has been proposed to him by his surgeon.
No, no,
So
that's
yeah,
what.
Maybe, doctor, once again. So I will show you the just a minute. Sorry, I will show you the complete
Sir, I'm
picture.
not
You
asking you
can.
sharing anything, but I'm asking, can we do something where we can do have a two parts, so that later we can
Yes,
fix it on that.
yes. Actually, I am not finished yet, so I have few slides. Maybe I will give you all the answers in that. Maybe we
Okay.
can have
Second
a
point
section.
is that if you are using a regular prefabricated screws, they will be having
Yes.
some metallic reactions. Do you think that way?
No, no, no. There is no matter because the screw holes that we are giving is exactly going to fit perfectly. At the same time, it
No,
won't
no,
give
I'm
you.
not talking about fitting. I'm talking about the any kind of a metallic reactions because two different metals.
No, no. It's
Because
the
there's
same metal.
some articles where they have shown that if you have a two different metals using for the
Mm,
same area, they'll having
mm.
some kind of galvanic reactions because the fluid will be there. Some sort of. That's not my experience. I'm just asking you because I wanted to
Yo,
clear that.
no, the same. The everything is a titanium. The screw that you are placing a titanium screw, and the implant that I am giving is a same material. The thing is that method is different. This method is different. They are preparing it in a different manufacturing technique. I am preparing in a different manufacturing technique. But the material, the composite, everything is same. There is no
Okay.
two different metal.
Okay. Okay. Thank you.
So
thank
That's
you.
this
also
is,
wanted to clear
yeah,
because we
this is a surgical image. You can see it here. So this is how they have placed it. Maybe you can see the operator. Same kind of case, Dr. Yasser Arafat. So we just planned virtually. We extracted the tooth. You can see it here. So different kind of measurements. Each and every step we do the measurement of extension. So we did this kind of U cut. So we carried with a simple guide. So this is an implant. We give it in a full scaffold stretches. So this is what the output, as I told you, so doctor, this abutment is not intended for all kind of cases. Okay, of course we are working as a screw retain process. Okay, it's a customized abutment along with a screw retain process. It's not that much easy to achieve, but we are working it. Probably we'll get it soon. Once we get a screw retain process, definitely everybody is going to use it, because currently this is only possible way of doing it. So of course we don't face any failures in this kind. I'm not much aware about this after surgical procedure, but we didn't any complaint. At the same time, the surface finish, maybe you can see it in a glossy finish and also matte finish. The surface has to be attached with the bone, has to be a matte finish for a better osseointegration or fixation as well. The surface has been attached with the soft tissue. uh, should be a glossy, because maybe we usually do it at a matte finish for all the way, but meanwhile one of the surgeons suggests us to should not go it with a soft tissue attachment, because if some infection, it may spread easily. If it is a glossy finish, we can avoid this. So based on the new ideas, based on the expert advice, we used to improve. So this is not a final product. Everything is not a final product. Everything need a improvement. So day by day we can improve, we can increase the quality based on the feasibility. You can see the surgical pictures. So as one of the surgeon asked me, so this is how they have sutured it. Okay, so this is what they are doing it so far. Cranial, of course we are doing a lot of cranials. It's very risky cranials. Maybe it's a kind of prosthetic. This kind of things are not achievable. Very thin. It's an example of very thin. The edges of the implant we just achieve in 0.6 or 0.8 a form of slice. Implant thickness, metal thickness, you can see it here. Same kind of, because we have a surgical image here. So here you can see the pictures of how they have placed it and thing. Of course we created this kind of structure. Maybe in this there is no need of osseointegration anything, but I used to create the scaffolds to reduce the size, weight of the implant. Maybe a few people are asking, why can't we use peak polyether ether ketone? So of course if the patient is going for the further any cancer treatment, they are going for the exposure of MRI something, we can't place a metal. In this case we can go for the peak, but peak is 4 to 5 times higher than the metal. Okay, peak is not a 3D printing. In peak is in a research level. Peak they are doing in a milling. If in case if you are doing a milling process of peak implant, our metal implant is lesser than the weight, because our metal cranial implant size is 1 to 1.2 mm of thickness we are giving. Okay, at the same time, since we are giving this kind of structure, that's comparatively is very lesser. So that's what we are using a metal so far. Maybe peak, maybe in the future. It's not in all kind of applications. So you can see it here. So as I told you before, each and every design, each and every methodology is not required for all the patients. It's not required for necessary to do it for all the surgeons. Maybe everyone will have their different idea, so we are here to create it. The world is nothing but we are creating each and every technique. So we are going to use it. Maybe in 3D printing will have a very different future in all the industries. But in medical it's totally different. Last when I have my first presentation in Stanley, no one has listened. Mm, Now I'm able to get it in a different way, because last 7 years it 3D printing has created a very big change. It's helping surgeons in a different way. It's totally changing a way of approaching. Maybe a few of the surgeons may experience with this kind of surgical assessment. Maybe freeform and Geomagic freeform and haptic device and D2P will work in a great way. So it's a two software will give you a complete solution. I don't have much experience on doing as a Dr. Divya asked, do you have experience on doing a dental or something? We have not yet received any cases. I'm not telling not possible. So everything is possible. We're just going to implement what we are doing on theater or on treatment. We can do it in virtually. So of course, it's maybe a future. Maybe it's a cartonic now. So 3D bioprinting is a next level. There are a lot of researches going on. Um, Thank you. So you can, of course, you can contact me in direct. Maybe you can mail me if you have any queries or something. So maybe a lot of service providers are there. You can contact anybody you are friendly here. So thank you for the opportunity. Let me know if you have any queries. I'm here. Maybe if we don't have much time, maybe you can contact me in direct. Thank you, doctor.
Thank you. Thank you. May I present you a certificate for your wonderful lecture,
Thank you.
virtually though?
Okay, ma'am. Thank you. No.
I'll put it on your email as well.
Sure. Thank you so much.
So we want to present you this certificate
Okay, ma'am.
and I will mail it to you. Thank you.
Sure.
Thank you so much
Thank
for being here today. And
Yeah.
I had a question. What FEA software are you using for your FEA analysis? That was my
ANSYS.
question to you.
ANSYS.
ANSYS?
ANSYS. Universally, they are using ANSYS only.
Okay.
I
So,
also have a small question.
yes, please.
Yes.
Have you done any corrosion evaluation of the implants you have printed? Any tribo corrosion sort of thing have you evaluated?
Corrosion, no, we have not yet done. But the thing is, doctor, we don't need to do it, because the material supplier, no, they have a certificate. They have done a lot of research. They have a certificate of corrosion value, everything. So the thing
Because
is, I am not
the-
creating any material. I am just utilizing standard materials.
but the fact of the design of the customized implant
Hmm.
may have some corrosion with the surrounding structures. I
No,
have
the
I have gone
corrosion.
through paper,
Yes, maybe you can
maybe by
gone through the
Mercury.
paper, but the thing is, the corrosion will not happen because of the design. It happened because of the placement that we are located. It happened because of maybe the fluid flow,
Okay.
the blood flow, whatever maybe. Design will not be related to any metal things. Design will related to only one thing, that is failure because of load bearing. If I create a very thin structure on the highly load bearing area, it may break. It may failed. That's the only possibility by using a design. Maybe if we created a very huge implant with a high weight, it may fail because of the load bearing in the fixation point. The screw may get loose. Okay, the corrosion with directly related to the material, how they have printed, how they have manufactured by using if there is any contamination. Maybe if they have any contamination, there is a possibility of getting corrode. If there is not proper post processing, there is a post processing or ball milling, heat treatment. If they have not yet done any of this, it definitely
Actually, I have gone through a paper published by Mercury, the group of Mercury printing
okay.
Yes,
TMJ.
yeah, yeah,
Okay.
So
yeah.
they have in 2014 that paper was what I remember 2014 or 15.
2012.
Uh, they have a study on tribo corrosion. So I
Okay.
was wondering if we can if there is something of certification to evaluate the tribo corrosion or triobiology, so that we can get a certification or plan a certification for that or have
Yeah,
experience on
but
that.
the
So
thing
that is
is,
why I
but
was asking.
not for us to do it very. It's not an easy task for us, because this process has to be done by the
Similar
material
question was Dr.
manufacturers.
Abdul Singh was the same, that that if you have a different materials, then also that there are electrochemical corrosions and tribo corrosions. So
Okay.
that's
Okay.
why I
No
asked.
different
Thank you.
material.
Thank you.
Single material. Single material. Yes.
Okay, and what is the cost of this NSYS software, if I may ask?
Doctor, it depends. There are different modules there. Maybe it start from 4 lakhs or 5 lakhs yearly.
Okay.
Maybe if you are interested by, I can suggest you somebody. You can contact
Yes,
me. I can
please.
suggest
Please
you
connect
proper
me
setup.
to those people
Sure.
who are into this business. Can we
Sure.
have the videos on for a quick photograph? Please, all of you, please have your videos on. रवि तुम तो अपना छुप ही जाओ so I think thank you.
Okay. Thank you for that, doctor. Okay. If anyone having any queries, please don't hesitate to contact me. It's not a commercial. As a researcher, I used to do a lot of new research. We are open to do a research, maybe studies, whatever we
I will
want.
disturb you quite
Yes,
often now.
I like it. Please.
Okay,
Okay.
so
Okay.
tomorrow we'll be joining back again, same time, same web link, and we'll have IIT Kanpur professor speaking on FEA. Okay, so see you all. Thank you.
Thank you. Thank you.